Yeah, okay. Thank you. Our hero. So our bridge stock today is divided. We have in different constructed form and materials. So we have an amount of 70% of pre-stressed concrete bridges, 17% of reinforced concrete bridges, formerly bridges with a length less than 20 meters. We also have some wood and stone bridges, but I think they are to be neglected. And we have an amount of 13% bridges made of steel and composite bridges. These are our bridges over big valleys and rivers with big spans. So how do we do our maintenance and how we do assess our bridges? We have external visual inspections. We have regarding 3 points. One is stability, one is durability, and the third one is road safety. All ends in a grade for the structural condition. And as you see on the right-hand side, you have an inspection vehicle. The inspectors, the engineers are looking for each crack, and all cracks of our bridges are registered in a database, and all plans are also in this database, so that we have a very good overview of all our bridges. And you see that the grade of the structural condition is going a little bit better in the last years, and we hope that it will be better also in the next years. But this is only one view on our bridges. We have a massive traffic increase. As you see, in the 1950s, there are more cars than cars on the motorways. And most of our bridges are built in the 1970s. And what you see is you have now a breakdown lane, but you have not that much heavy good vehicle transports, but you have more cars. So and today normally the breakdown lane was changed into a traffic lane. We have a very much increase in heavy good vehicle transports. They are dominating our traffic. And even after the reunion of Eastern and Western Germany, we have a massive increase in traffic from east to the west. So let's see also the types of the heavy good vehicle traffics were changed. Today the type 98 is dominating our traffic, but this type leads to a heavy damage of our structure. So in the blue line you see it's the increase, including the forecast of the heavy good vehicle transport, and what you see is that the forecast says that there will be no limitation in the near future. So our situation today, as you see, we have limitations of weight, especially you see on this side the Leverkusen bridge. We have distance orders, we also have speed limitations, and all of this leads to a traffic jam. So we knew that our external view, the grade for the structural condition, is not sufficient to reflect the load-bearing deficiencies of a bridge that result from massive increase in heavy good vehicle traffic, and does not reflect deficiencies in the original design regulations. As I said, they were built mostly in the 60s and 70s. So the assessment of the load-bearing capacity of a bridge is conducted by now comparing the envisaged load-bearing capacity, the so-called target load level, with the existing or proven bridge grade of a structure. So therefore, we will introduce in this year a load-bearing index. So what does this mean for our bridge stock? It means or we know that these bridges will not get the target load level without reinforcements or replacements. I will show you this by the example of the Rhine Bridge at Leverkusen. The Rhine Bridge at Leverkusen is the most well-known bridge now in Germany. Every politician knows when we are talking about Leverkusen, we are talking about a bridge that is here at the side, and we have here very much traffic. We have here at the port of Rotterdam, one of the most important ports in Europe. We have up here near to Leverkusen Europe's biggest chemical area. We have about here the powerhouse called Ruhrgebiet. It's especially known for its steel fabrication. And we have up here, it's not shown directly, there is Duisburg, and Duisburg has the biggest European inland port. So a region with heavy east-west traffic and heavy good traffic. So let's have a closer look. You see in the 60s and 70s there were much roads that were built, and also these roads and bridges are older than 50 or 60 years. So the Leverkusen Bridge is a bridge over the river Rhine, and it's going from Cologne to Leverkusen, and it's only one bridge. It has only one structure. So we have a traffic volume about 120,000 vehicles a day, and a heavy good traffic about 12%. As you see, the bridge was constructed in 1965 and has a big span about the river over 280 meters, and was designed for a bridge grade of 60. This means about 60 tons for load capacity. So give you some more data. Surely in 1973 we had the first cracks in the orthotropic deck plate. This is because of insufficient material. The steel had no good quality in the 1970s, and the cracks in this deck plate occur again and again today, and we have till now over 2,000 cracks in the plate. In 1986, the use of a breakdown lane is a third lane, and in the 1990s, the construction of additional noise barriers on the bridge were common, but this is typical also for other bridges. In 2007, first cracks on the load application stiffeners at the lower connection points of the diagonal braces in the interior of the box guiders were shown. We started, therefore, a reinforcement of the structure to eliminate the static deficiencies, but when you don't do the traffic away, the old structure don't will sufficient the more and more traffic increase. So in 2012 there was a serious cracking in external upper frame corners, which leads to the blocking of the bridge for heavy good vehicle transport over 3.5 tons over several months. So in 2013, an assignment of a planning for order replacement was established. In 2013, cracks in the cable chamber and on the cable traverses leads to reblocking till today. Last year, we had a building legislation and assigned the building contract, so that we hope that the first substructure will be implemented in 2020. So let's have a look on the cracks. As you can see in the pictures, we have on the longitudinal stiffness, we have massive cracks on the right-hand side over 1 meter, also at the cross griders on the left-hand side. We have in the lower frame corners, these are the cracks of 2007 at the diagonal braces and the lower connections points where the load implement stiffeners began to crack at the front. And finally, the upper frame corners in 2012, which were the serious cracks, which leads to the blocking, as you see up here. Yeah, what have we learned? We have implemented since 2011 a guideline for the recalculation of our existing bridges, the so-called recalculation guidelines. We have a quick assessment established for the load-bearing capacity of smaller bridges. We have introduced reinforcement methods and regulations, a companion for strengthening of older concrete and pre-staged concrete bridges, and we have pilot projects for the reinforcement of orthotropic deck plates, especially the sandwich plate system, to spread the load impact. And this year we'll reinforce a bridge over the Rhine in southern Germany with a composite topping made from ultra high performance concrete. So the bridges, particular bridges over the Rhine, are hotspots in Germany and hotspots for the transport network. So closing one of these bridges means we have much detours, and today I can say we have also another bridges next to the bridge of Leverkusen that will or had to be replaced, and the more detours of the heavy good transports will damage these bridges more and more. So you have when you close one bridge, another will get more traffic, and they are falling. So yeah, what did we learn? We implemented for the maintenance, especially for bridge reinforcement and bridge replacements, to funding. So the funding of maintenance for engineering structures was made up in 2016 of 3.3 billion euros, and which will run up to 4.2 billion euros till 2020 for each year. We have a forecast of structural maintenance requirements till 2030. So the share of funds for structural maintenance of the federal trunk roads that is spent on civil engineering structures will be around 36% until 2020 and will increase to approximately 43% in the year afterwards. But to speed up implementation of necessary strengthening works on the federal trunk road network, a bridge modernization program was launched in 2015. So we started in 2015 with 360 million euros for each year, and increases till 2021 to 850 million euros each year, but only for big bridges over 2 million amount. And therefore we have also included a basic amount of 100 million euros annually for smaller bridges. And as a forecast, this money will also be needed and spent after 2021. So funding is not funding without any strategy. Therefore, we implemented first, or we identified in 2010 priority bridges. But then you have single spots in your net, and this is, you can't handle it. So last year we implemented or identified a priority road to manage the traffic on the so-called priority bridge network. So the bridge leads to the construction activity and not the road. That's a new approach. So the objective is to establish by 2030 a seamless network of federal motorways routes on which the bridge structures have the necessary and future-proof load-bearing capacity. We are estimating this cost around 9.3 billion euros. So let's have a look at the priority bridge network. It's correspondingly normally to the Trans-European Road Network. And when we have a closer look at the region of Leverkusen, you see many red dots. All of these bridges have to be recalculated, maybe reinforced, and maybe replaced. So what do we have, especially for our steel and composite bridges? The objective is to develop design and draft recommendation, and what's very important, at the same time, we have a big research project on the future proofness of the current fatigue load models. And this project also addresses questions on the future volume of traffic and expected transport characteristics, so that we hopefully then future-proofed. So I will come to my conclusion. So there is a high demand on reinforcements, replacements, and modernizations. Therefore, we need construction site planning. Therefore, we need engineers. That's a really big problem. You need building legislation, especially noise and nature topics are very important. We have low traffic influence, hopefully in a high frequency network, and of course effective research usage. This means to develop new ideas, to experience in dealing with existing substance. You have to decision-making competence, decision-making courage. And hopefully I can give you a good outlook with the new Leverkusen bridge in 2020 for the first substructure, and the new bridge will cost about 400 million euros. Thank you for your attention.
Thank you very much for your presentation. Perfectly on time. And I want to let the last speaker talk before we take questions, if you are ready to take one coffee less afterwards. Mr. Manuela, with saw damages, with our ideas for money, for managing all those